This is section 3.1, part C. I'd like to take a look at this algebraic fraction, 4x minus 9 over 9 minus 4x. You can clearly see that we've got the same two terms subtracted, but in the reverse order, top and bottom. Look at what would happen if I were to factor out a negative 1. That would make this a negative 4x, and it would make that a positive 9. Okay. Now, I know subtraction is not commutative, but the addition here is, I could write the 9 first and the minus 4x second if I wanted to. And of course that would mean the same thing. But it also allows me to see very clearly that I now have the same factor in the numerator as what my denominator is equal to. This is technically times 1, even though it's not written. So we really do have multiplication top and bottom. A multiplier of negative 1 times our binomial, and a multiplier of positive 1 times our binomial. And that allows me to reduce. 9 minus 4x divided by 9 minus 4x is just 1. When all is said and done here, I have negative 1 times 1 divided by 1. And that, of course, is just going to give me negative 1. So I went through this whole example step by step so that you could really see why this happens. When you've got a factor that's identical except the terms are reversed in their order for subtraction, the same analysis is going to work every single time. You're always going to be able to factor out a negative 1. And therefore, usually when we do this, we stop writing out the whole process, and when we notice this pattern, we simply say, oh, I could divide those, but they would divide to negative 1 instead of positive 1. Let's take a look at that kind of in the context of a larger problem in example 6. I definitely need factored forms. And I'll start on top. That's a difference of cubes. Again, one of the formulas that I didn't ask you to memorize, so let me just remind you what it was. It looks like that. And in this particular case, A is just 1. Cube root of 1 is still 1. And the B, the cube root of 27x to the third is 3x. So let's go ahead and put those values, that's B. Let's go ahead and put those values into our difference of cubes formula. A minus B is 1 minus 3x. A squared, 1 squared is still 1. Plus A times B, 1 times 3x is just 3x. Plus B squared, 3x times 3x would be 9x squared. All right, so there's a nice factored form of the numerator. We'll turn to the denominator next, and I'm going to need a little space on this one. I have a trinomial, so I'm thinking sum and product. I'd like a sum of 7 and a product of negative 60. Let's see. What have I got there? 12 and 5? If I make the 5 negative, those would add up to positive 7, and definitely multiply to negative 60, so I think we're good there. So I've got my 15x squared, split up the middle term, plus 12x minus 5x, minus 4. If I now factor by grouping, in the first group I can factor out a 3x, which makes that 5x plus 4. And in the second group, I'm really factoring out a negative 1, since there's no other value that I could divide out of both terms. But because I'm taking out a negative, it does become positive 5x and positive 4 inside the parentheses. Common binomial is 5x plus 4. And when I factor that out, I'll get 3x minus 1. So all of that is going up here in my denominator. 5x plus 4 times 3x minus 1. All right, I would like again to divide some things out to simplify. And we'll notice on this one that we've got a situation very much like this. I have a 1 minus 3x, and then I've got a 3x minus 1. The same two terms, but the order of the subtraction has been reversed. I could go through all these steps again, or I could simply say that when that happens, I can divide these two values and end up with a negative 1 instead of a positive 1 when all is said and done. And that's the quickest and easiest way to handle this. As far as writing the final answer, I can take this negative and just bring it right out in front of my fraction, which is probably what I'm going to do. Or I could choose to distribute the negative through the numerator. That would also work. But I'm just going to put it in front. All right, so watch for that one little shortcut, or tricky step, if you will. If you do have two factors that are the same except they're subtracted in the reverse order, they can still be divided, but they divide to negative 1 rather than positive 1. All right, that is the end of section 3.1.